Hi everyone. So today we will discuss thermodynamic part asked in Neet exam previous papers. So very first question is, what will be the value of delta H if forward and reverse reaction have same energy of activation? So let us draw its energy profile. So this is your energy profile. These are reaction coordinates and this direction is energy. So both the forward and backward reaction have same activation energy. Now what is activation energy? This barrier which should be crossed by the reactant molecule to convert into product. So let us consider this is forward reaction, reactant are converting in product. Now this is backward reaction where product are converting into the reactant. So both in this reaction both are having same activation energy. What is activation energy? This energy difference. This energy difference, this gap is called activation energy. This gap is your activation energy. So it means the enthalpy of reactant which is represented as HR and enthalpy of product that is equal. So because enthalpy of product is equal to enthalpy of reactant, so what will be the delta H? Delta H for reaction is enthalpy of product minus enthalpy of reactant and that will be equal to 0. So this is the answer. What about other terms? Delta G is equal to 0 or not, because delta H is 0 in A and D. So B and C options are incorrect. So it means all the three can be 0, but it is not possible. Delta G is del H minus D del S. So delta H if is 0, it doesn't mean that entropy of system is also 0. So it is not equal to 0. So our option number D is correct. A option is incorrect. Next question is, we have this data, thermodynamic data, and from here we have to find the relationship between X, Y and Z. X, Y and Z are the enthalpy change of reaction of these three equations. Now we have to solve these three equations such a way so that we can get a particular equation. So on observing we are seeing that it is half mole of O2. It means we have to use these two equations in order to get this first equation. So how can we get first equation? So just by adding, because we don't require carbon graphite must be must remain at the end of solution of your equation. It means that remaining that you don't want carbon graphite should remain and O2 and CO2. So it doesn't have CO component, so CO must be cancelled. So how can we cancel this CO? By adding these two equations. So we are just using 2 plus 3. Upon 2 plus 3 what we are getting, CO will cancel out and we will get the same equation as this equation number 1. So it is half plus half, so it will be 1 O2 and then on right hand side CO2 gaseous. So in similar way, because delta H is extensive property, so it can follow mathematical addition subtraction rule. So we have to just add this equation. Let it be delta RH naught dash and this is equal to Y plus Z kilojoule per mole. Now this delta RH naught dash, this is equal to because this equation is similar to equation number 1. So this is equal to delta RH naught. This is equal to delta RH naught of first equation. So first equation, this is X kilojoule per mole. So what is the relationship? X is equal to Y plus Z. So our option number C is correct. Next question, what will be the function of catalyst in a chemical reaction? So what is the function of catalyst? It decreases rate constant. It is incorrect. Rate constant is direct measure of speed of reaction. Catalyst speed up the reactions. So this is incorrect. B, it increases activation energy. No, it never increases. Rather it decreases activation energy. So this is also wrong. It reduces enthalpy of reaction. It is also incorrect because there is no relationship of this enthalpy of reaction with the catalyst, because enthalpy of reaction is the enthalpy of reactant and product, the difference between the two. So it does not affect equilibrium constant. This is correct. Next is, what will be the work done 3 moles of ideal gas when it expands spontaneously in vacuum? What do you mean by vacuum? Vacuum means external pressure is equal to 0, and whenever we are writing a work done expression, we are writing always the opposing pressure, because the gas is expanding. So what is the opposing pressure? It is external pressure. So it is P external delta V. Okay, here P external is equal to 0, so W will be equal to 0. Work done is 0. Option A is correct. Next question, find the temperature at which equilibrium will establish if your entropy change and enthalpy change are these respectively. So what is the value? And this is your reaction. Here enthalpy change and entropy change are 30 kilojoule per mole, and delta S is 105 joule per Kelvin per mole. So we have to find the temperature. Which temperature? When equilibrium is established. So we have our equation, thermodynamic equation, where all these three terms are there, and that is Gibbs free energy change. It is delta H minus d delta S. Now at equilibrium, delta G is equal to 0. Delta G is equal to 0. So this equation will become delta H minus d delta S, or we can say this is true only when delta H becomes equal to T delta S, or T is equal to delta H by my delta S. So upon putting the values, this is 30 kilojoule per mole, and your entropy change is 105 joule per mole per Kelvin. So in units we will be getting joule will cancel out, mole per mole will cancel out, Kelvin inverse, it will become Kelvin. On rearranging these terms, so we left with 30 kilo means 10 to the power 305 Kelvin. Upon solving, we will be getting 285 point something. So your answer is D. D answer is correct option. Ninth question is, an ideal gas is expanded isothermally at 300, and this data is. So one thing I want to explain you, or I want to tell you, that whenever your gas is expanding isothermally, your change in internal energy is always equal to 0. Why is it so? Because you are carrying out a process of a system at constant temperature. Temperature must be kept constant. So actually your gas is expanding. Previously your piston was at this position. Now your piston has been moved by this volume. So this is the volume change. But what is happening? Because the system is doing work. Work is done by the system. It is done by the system. So it means it is accompanied by a decrease in energy, because we need some energy to do the work. So we need energy. So we are consuming the energy. So when the gas will expand, temperature of system will decrease. System will decrease. In order to keep temperature constant, what we have to do, what the system has to do, system has to absorb heat, so that temperature remain fixed. So how much heat will be absorbed by the system? It will be equal to the amount of energy consumed by the system. So it means your heat absorbed is equal to work done by the system. Now what is sign convention? Because work is done by the system, it is by the system, and heat is absorbed by the system. So you are adding here Q is taken positive at that time, plus Q, and this is equal to, done by the system, it is equal to minus W. So according to first law of thermodynamics, delta U is equal to Q plus W. Upon putting the value of Q, which is minus W, it will be minus W plus W, so it will become 0. So this is the correct option. Or directly you can remember this thing, that whenever this process is isothermal, delta U is always equal to 0. So no need for further calculation here. So this is the last question of thermodynamics, and it has been asked delta H, value of delta H or expression of delta H has been asked from here. For this equation it is Haber's process, nitrogen gas, hydrogen gas and ammonia gaseous state. So what is the relationship between delta H and delta E, internal energy change and enthalpy change? Delta H is equal to delta E plus P delta V, or delta E plus delta Ng RT, by using ideal gas equation. So as our option contain RT, it means we have to use second equation for this. and from here we have to find the value of delta Ng. Delta Ng is number of gaseous component of products minus number of gaseous component of reactant. So just count here, count from here. This is your product side, this is your reactant side. Number of gaseous component here are 2, whereas reactant side 1 nitrogen and 3 hydrogen. So 1 plus 3 is equal to 4. So you have to subtract reactant minus product, that is 2 minus 4. It is 2 minus 4. The value of delta Ng is minus 2. So put delta Ng in given equation, you will get the answer. So delta H will be equal to delta E minus 2 RT. So this is your correct option. So that is all for the day. Thank you so much. Option is correct. Thank you so much.